Hi everybody. If you missed our assignment in class, Shadow Plots a First Look, want to go over some really important concepts that we discovered. We put actually a little toothpick right on our gnomon and actually used our flashlights to try and mimic what it would do to make these points. And this is draw the motion that the flashlight goes through to mimic the sun. And notice that the shadows go from really long to shorter, and then they start getting long again. We came to the conclusion that the motion of the sun, as well as the motion of our flashlights, if this is the ground, the motion of the sun follows an arch. And that arch has a name, and that name we call the ecliptic. And the ecliptic is an imaginary line, much like the equator or the orbital plane. But if the sun left a trail as it went through the sky, that trail would follow the ecliptic. And so this was the motion that it goes through. And it's this arched motion that we call the ecliptic. Then we had when are the gnomon shadows the longest? And what does that tell us about the altitude of the light? Well, they're longest in the morning and in the afternoon, and that tells us at those times the sun's pretty low because the shadows are long. And as we go to midday, they become shorter and shorter. At some point, we hit a shortest shadow of the day, and then they start getting longer again. Okay. At what time of day does your flashlight have to be held the highest? Well, that's at middle of the day when those shadows are very short from the gnomon to the shadow point. Next one, shadow plots can't be started exactly sunrise or sunset. Explain why this is true. And the easiest way to explain that is with a drawing. And that is simply that if this is the ground and this is the gnomon, if it is right at daybreak, right when the sun comes up, the sun looks like it's right along the ground. That means that the light's going to hit the gnomon like this, and we're never ever going to get our shadow triangle to hit the ground. The sun has to come up a certain distance in order to get that shadow point that is going to hit our paper and make a dot for us. So we can't do that because simply the shadow points aren't going to hit our paper if we do it right when at sunup or sundown. 5, what does the tip of the shadow tell you about the location of the sun when it was made? Draw a sketch to illustrate your answer. Well, what we want to realize on this is that if the gnomon was here and at 9:41 a.m. it was making a shadow right there, well, on a straight line opposite that is where the light source would have to be, because light travels in straight lines. It gets blocked by the gnomon, and then that shadow goes out there to 9:41. And on your paper, you could simply have drawn something like this. An X, which we hopefully know now means gnomon, a shadow point, and just drawing a line with your ruler. I'm doing this freehand, so mine's not quite good enough, showing that the sun is always on the opposite side of the gnomon as the shadow point. So again, the shadow points work like reverse pointers to the sun. In the morning right here, the shadow went from there to there. The sun would have been over here. In the evening, the shadow went from here to here. The sun would be over there. And in the middle of the day, the sun would be down here. But it's moving around the sky all day, or at least it appears to be moving around the sky all day. Okay? And then how does the length of the shadow change during the day? Well, we've already said that. It goes from long to shorter to shorter to shorter. It hits a shortest point, and then it starts getting longer again. Okay, so make a line that connects all the data points on the shadow plot. Is the line an accurate measure of where the shadows were during the day? Explain. Well, what we want to do is just exactly what it says. Make a line as best we can that's going to connect all of these points. And the question is, does that line represent reasonably where the shadows were all day long? And in fact, it does. And here's how we can think of this. If I asked you to figure out or make a guess about where the shadow point was between 8:30 and 7:40, which we didn't have a time for, you're not going to draw it way up here. It makes no sense that every one of our shadow points kind of follow this line, but this one's up there. You're going to guess that it's right down here someplace. If I gave you the world's most boring assignment, which was to go out and make a shadow plot, but every 30 seconds make a dot where the shadow is, you'd have a whole bunch of dots by the end of the day. As a matter of fact, you'd have so many, they would move into one straight line, and that line would look just like this. So even the places here where we didn't get a shadow point, there were definitely shadows that hit on the line at that point. So that is the idea behind number 7. Now, number 8 gives people a lot of trouble. It says, in math, you've learned a term called a line of symmetry, which breaks things in half. So a line of symmetry, just for a little math review, is going to be something like if you have a square or a rectangle, not a square. This has 2 lines of symmetry. One line of symmetry is right like that. The other side, because you could fold it and it would meet. The other line of symmetry is like that for the same reason. Again, mine aren't perfect. I did them freehand, but that's a line of symmetry. So the question would be, do our shadow plots have a line of symmetry? And we need to go back and think about our ecliptic. Now, does the ecliptic have a line of symmetry? And hopefully you can see that it does. We've got the highest point on the ecliptic. That highest point has got a special name. It's called local noon. And it basically splits our solar day in 2 equal pieces. Here we have the sun low, coming up, hitting its highest point with its shortest shadow, and then going back down again. So if the ecliptic has a line of symmetry, certainly a shadow plot would. And notice the line of symmetry on the ecliptic is its highest point. So the line of symmetry on a shadow plot is going to be when its shadow is the shortest. Now, we can't guarantee that we actually went out and made a point during that time. And in fact, we didn't. During this day, the shortest shadow of the day, or local noon, occurred just about in between 1240 and 1:30. So if I make a line that just goes from the gnomon right through that point, and I fold the paper on that line, notice that the 2 halves of my line match up pretty perfectly. Now, they're not equal lengths because we can't take precise times like that, but they all open up, and this side of the line is like a mirror image of that side of the line. So shadow plots all have lines of symmetry. That line of symmetry occurs at local noon, which is the shortest shadow of the day, which also marks our highest point of the sun. And that's it for shadow plots. I think you can get the last 2 questions on your own now that you've had that. But that's what we wanted to see in shadow plots at first look. Ecliptic, local noon, even on both sides, so forth. Okay? Thank you for watching.